swift of foot versus
Hi,
keen
I'm
of eye.
AJ. I'm swift of foot.
Are you?
Hi, AJ.
Your foot will swiftly go somewhere.
Yeah, I think I didn't get a chance to do a control van quick intro. So in the front row, we have Johan on navigation. We have Jake on
Shout out to Johan.
really carrying the dive today.
Yeah, really doing all the work.
Thanks, Johan.
It's a team effort.
I'm sad that the camera only gets like you in the very corner. I feel like you should have a spotlight tonight.
I mean, I can switch it to nav cam, and it's really
all right.
close to his
Really
face.
aggressive.
Yeah, it's like right here.
we reserved that one for Rennie.
Amber was definitely kind of sabotaging all of us with the cams
Oh.
yesterday.
Oh no, what
we
happened?
found out that video has all the power, because
Yeah.
if video's upset with you, you'll just get a big close-up of your face on.
Yes.
Did you not think video had all the power before?
No.
Exactly.
Who else did you think was controlling the video?
I just didn't realize how much leverage they had by having cameras like up all of our noses.
Yeah.
I mean, I'm just curious what you did to upset Amber.
I want to know now too.
So would I.
He questioned her power.
And then next to Johan, we have Jake on Hercules controls, and we have Anna, who is usually our video engineer, but she is sitting in the Atalanta control seat. Our video engineer seat is empty right now.
Yeah, well, I mean,
No one's got the power.
we're not really
I
looking
can
at much.
switch seats easily. I can jump over there in an instant.
Anna wears many hats.
I
Yes.
And change the color of blue that you're seeing. And
Yeah.
Right, unbalance the white.
Yeah, really fun stuff.
And then we have Steph over in the back row here as our data logger for tonight. We have AJ as our dive lead. We have Steve, our scientist, and myself, Yuko, in the science communication seat. Who do we have on shore supporting the dive tonight, Steph?
We've got Keegan and Grant.
Hey, Keegan. Hey, Grant. Dream team over on the shore side.
Oh, yeah.
so back to the survey at hand.
Of course.
What's the Jake? We're over a fairly flat area, so this is a good way to really sense the accuracy of the Norbit. And so we get three little lines that are developing there that are parallel, looking sort of parallel to the pass. Maybe not. They're actually off to one side, aren't they? Yeah.
Those 45 degree?
Yeah. What's going on there? Is that real?
That's just the slope.
But why is it jumping? From
I think that's just the resolution of the cubes.
the cubes. The cubes just are only there, and then the next meter there's another cube.
Yeah, so you can see we're on a
Yeah.
slope here.
Okay, so that's a side, so we're actually climbing. No, we should be going down, shouldn't we?
But angle to us, like we're not going straight down the slope.
We're going right across along this slope.
So it's shallower to the south of us.
Correct. Which
So-
is true here.
Are we looking for anything in particular in their survey, or just kind of getting a general sense of the area?
I think the main reason we're doing this is just if we decide or can come up for a reason good science reason to place a
Junction box.
a node at the trawl resistant frame we just looked at, we would want to, lay a cable, and this would give us a good view, a pre-cable leg thing, which is, I think the way to do it is to see if there's anything that could mess you up laying your cable, rather than a post-cable leg.
We were coming from a very flat section where that trawl resistant frame was, but as we approach the vents, I imagine this might get a little more interesting bathymetrically.
And I don't think it slows us down too much. When we're going 0.3 knots, what's the norm? What's our rapidest?
0.5 maybe.
Yeah.
But then 0.5, but then approaching the vents, you slow down and do a bunch of ship moves anyways, so you don't hit vents and stuff.
right? Well, I don't think the relief is quite, here, I'll bring up some of the maps that probably Katie would be familiar with. Somehow attributed to Dave Butterfield.
So Dr. Katie also wrote in a little earlier saying that in 2014 when they were there was a 9-meter tall chimney at the dead dog site that was new. So that was 2014.
Yeah, that's what we're trying to figure out if it's, if there, I mean, there could be, basically 2 ways it goes. There could be a ton more chimneys there and it's really active, or the whole thing could be dead, as the dog would be.
Oh, Steve.
And puppy dog would be grown up.
Would just be a dog,
but bigger.
Steve, has Anna been participating in the objectives here? Have you heard from Anna?
Anna.
Out east?
Texas?
Yeah.
No, I would have tagged her more on the Tempo Mini placement.
Oh, okay.
But I didn't.
I thought that they wrote the paper on Middle Valley.
Verena and I can't remember. There's some papers that I didn't come across them in searching for this map stuff.
Oh, that makes
the
sense.
mapping was mostly done by the
What?
What did you just do?
the court guys.
Right. ODP.
Yeah.
If I right-click and drag,
But I'm sure we were here,
kinda
like
get-
Ropos was here as well.
If you look
Yeah,
at your
I think
nav
that's
screen,
what they used for the paper.
it gives me like the range R. So this is
And that's where the
70
dogs,
meters away,
my
and
dog
the bearing
myth
V,
came from.
and that
Your dog.
helps just like
Esca?
position where to go
No,
and figure out
the
how
dead
far away
one.
things are. Or
The dead dog myth.
if we see something in the
okay.
sonar, I can mark
Esca
it
doesn't come from-
approximately where it is and things
Cool.
like that. Yeah.
Deep diving.
Hey, Jake, I got a question for you here.
Yeah.
This viewer is watching the Norbit mapping, and they're just wondering why has Herc suddenly gone up and down. So I assume it was that the couple bumps right behind the Hercules there?
That was actually my fault. I was tweaking with things.
Okay.
Trying to dial in your PID?
Yeah.
What does PID stand for?
Proportional integral derivative. It's a controller that you use for closed loop control for control of different. I mean, you can use it for many different applications. But
So
you want to go, Steve?
we can now get into ordinary differential equations.
Yeah, we can go into a whole lecture here.
But that's what I was thinking. I guess it's you want to fix the eye.
Yeah,
So tweaking the eye.
I tried the eye, and I don't know, the system's been notorious for setting the eyes all to 0, and I tried tweaking the eye very minimally, and that's kind of what caused it to
there you
go
go.
crazy.
Well, because there's oscillation input, you don't know if it's
Yeah.
overshooting or undershooting. So your D could be too high or too low.
It's a mystery. I tried to just barely change it, and it started going wonky, so.
Looks good now. Look at that. It's settling in.
Yep, you did a great job. Look at that.
Forgot to hit another step forward, though, so.
Oh, that's why. It's been
Well-
stationary.
I guess you have to dial it into the C state. So whatever the input frequency is, which is this lumpiness we're getting, sitting in our
And then
chairs that go back
the
and
ship
forth.
changes its heading.
Yeah.
And it becomes more of a roll than a pitch. It's chaos, Steve. It's all chaos.
Yeah.
Are we
The-
heading?
The best way to look at this is
You
that
just go
simple
off about
Oh, okay.
15
ordinary
meters.
differential equation with
This
the
line
mass,
here is
Mass
a
spring damper.
viscous thing in the middle, a velocity one, and the spring.
Mass spring
Yeah,
damper.
mass spring
Yeah.
damper.
I think that's the one that you get a picture really well.
Yeah, that's the.
And it's
that's
the same
like
thing as a
your-
PID. But
Yeah, that's your PID example.
So that, I think that would mean the D is the viscous one then, not the I? I don't know which is which.
The D.
Proportional is the spring. So the distance away from where you want to be
But
spring.
there's spring, but there's spring X, which is proportional, and then
Yeah.
stiffness,
Yeah.
and then
How does that translate to
Yeah.
PID is what I'm
Your
trying to figure
first
out.
term, your derivative
Proportional.
term, and then your
yeah,
Okay, so it is the I.
yeah.
Proportional.
no, it's
No, yeah,
it's
proportionals.
derivative and
Vis-
derivative,
vis-
which is based on
viscous.
speed. The mass spring damper
Yeah.
doesn't have an eye control.
Yeah, so you should tweak the D.
'Cause-
But I don't think you should tweak anything because I think you solved it by whatever you untweaked. But look, yeah, it's flat.
Seems to be somewhat flat, yeah.
So for
It also depends on where the vehicle is. So, like, Atalanta's above Herc, which is better for this, but, yeah.
Yeah, maybe you didn't do anything. Just things
I
changed.
didn't do anything. It's back to the way it was.
in plain speak, in layman's term, what we're doing with Hercules is we're sending, and correct me if I'm wrong, everyone in control van, we're sending sound signals to bounce off of the seafloor. That sound comes back to the ROV, to Norbit, which is the sonar. Is it mounted under the ROV, Drake?
The orbit is mounted on the brow, right where the lights are, and some of the cameras.
Yeah, and so when the signal bounces, oh, thanks for the
You
zoom.
can see it.
Cool.
Zoom
Whoa,
all the way in.
Wow.
Right there.
that's awesome.
Awesome.
Thanks, Jake. Yeah.
That was Johan.
Oh, sorry, thanks, Johan.
It's okay.
I
You're
could
the
have taken
same
the
person
credit. I
anyway.
could have taken the credit.
It's taken us this long to learn that if anything amazing happens, it's Johan,
Yes.
secretly, quietly.
But the signal goes back to the sonar, and that's how we get the picture of the map in very, very plain speak.
Actually, Johan, Middle Valley might be a better place to put the DTS.
Oh yeah. It's
Flatter.
very flat.
Yeah.
Yeah, DTS.
Yeah, we'll see what we find. It looks like there's a little more feature near the vent area.
Johan's
Yeah, well,
DTS
if
data is super
Katie
cool.
says 8 meters, so that's getting up there.
Thanks, Jay. Trying to change the subject.
Anything Johan does is super cool.
So we didn't actually do a dedicated survey for the DTS, but I think you got a sense of what the options are and a bit of an idea of the field going north and going south through
Yeah.
those might be the most interesting engineering-wise to just understand I think going crossways down that cliff may not be, we didn't see the cliff. I don't think you saw the cliff, but it's a big cliff.
Yeah, I didn't like exactly at it, but based on the
You saw the
orbit map, yeah. It's a big cliff.
When you deployed it previously, were you going across mostly flat terrain, or was it?
On our first deployment, we only pulled out like 18 meters of fiber.
Yeah.
It's just like the first time that we got on the seafloor. The second time was like 2 fibers of 150 meters. And that time we went up some pretty, like 20 meter cliffs, I think. But it's just hanging off, so it's not really doing anything too useful.
Yeah.
But to get between point A and B, it works. We just had to weight it down so it didn't slide.
I've got a viewer wondering what something like a plane wreck would look like on the Norbit map.
like a plane.
Yeah, that's what I figured, but
There's got to be multi-beam survey of like shipwrecks and stuff available online. And that would probably give people an idea of how these looked in multi-beam.
Yeah.
I think most of the impetus to develop things like Alvin and these deep diving submersibles was to get the Russian plane in situ before the Russian gets to it and figure out what they are, get pieces. I think it was...
Oh, when would that have been, like in the Cold War, you mean?
Now we're getting the dangerous myth world. No,
Yeah, Steve spin some lies for us.
So, caveat. I think, yeah, I think there were three subs, Alvin, Turtle and Seacliff built, and this would be something OET's. I don't know what he is, a CEO or whatever. Bob Ballard would know a lot about, but I think the three sisters were Seacliff, Alvin, and Turtle, and Seacliff and Turtle, I think, were all Navy things for finding, crashed. Well, one of the reasons to do that, and Alvin was dedicated to science, and they kept that one going longest. I don't know what happened to the other two ROVs.
Those were used here?
They're not even ROVs, HOVs.
Those were used at these sites?
Alvin definitely has been here. I think Katie, who's still online, would have been in Alvin when they were talking about finding puppy dog and naming furry little dogs, or naming vents after furry dogs.
I feel like this site will now have to follow the dog theme, so we're gonna have to learn all the dog breeds. German Shepherd vent, Husky vent, Mountain vent.
I'm a big fan of Chowder Hill vent.
Well, that's the one. Yeah, that's the one that's there.
Chowder Hill.
Chowder.
Shout out to all the Chowder heads.
Would that be a soup category then? So it'll be different soups in that area?
Minestrone.
Minestrone mound?
Ew.
Gazpacho.
Minestrone.
See?
Oh my god.
We got Chowder Hill, Minestrone mound, cream
Are
of
these more
mushroom.
site names?
Yeah.
We gotta have chicken noodle. It's a classic.
Chicken noodle vent, yeah.
Yeah.
It would work really
Chicken
well,
noodle
especially
vent.
yeah, especially if there's a bunch of hydrothermal vent worms.
Dan's sitting video, now we're in trouble.
Oh no. Get ready for your close-ups, everyone.
All the zooms. Get your hair good.
I already finished my Fruit Loops, so let's have my little wrap meal
Dad,
back
do you
here.
know how to white balance? He's breaking out the controls over there.
I should have stuck this in for you guys on that, but that's our...
You gotta turn. Yeah, there it goes. Okay.
All right, we got Inspired
I
Mounds,
do know how to white balance.
Chowder Hill, Dead Dog Hill, East Hill, Heineken Hollow. That feels like product placement. Central Site. How much did Heineken pay for that? And then there's Bent Hill.
What's that?
Yeah, Bent Hills
You doing all right over
is
there?
another place.
Jake,
Another,
give you the tour?
but it's fairly,
No
like,
wet
that's
buttons
200
pressed.
meters, so
Yeah, it's spread out. It's not as tight in.
no, well, I don't know whether we want to do the full
Full-fledged
200.
Oh, I don't think there's a plan on
Better
us.
Atalanta pilot than I
I
am.
think I gave Randy, I think there is a plan of some sort.
Oh, okay.
Hopefully,
Oh, I see. Yeah, down here after the gas tights. That's how it's written. Because I think
Yeah,
the
the
gas
quest-
tights are higher priority.
well, what I was suggesting to Johan is we find, the only way to find this is to go to this 858G, so we have a position
Those
for that.
cork holes.
Yeah, so that's a cork there. So physically we'll see it, we'll
Yeah.
find it, and then we go just directly south to Chowder Hill.
Okay.
And then take a gas tight
Take a
there, and then
gas
figure out
tight.
how tough this whole area is to do all that stuff,
Yeah.
what time it is, and then do a quick Norbit scan to see if we can find any of these other spots. 'Cause otherwise we'll be going all over the place looking for these places that, and if we had a quick,
That's how we used to do it
There
before
is
the
no
Norbit.
such thing as a quick Norbit scan.
but we're
That's like
going
doing quick
50 meters,
photogrammetry.
and I knew where they were.
Right. Yeah.
What,
No,
sort
it's
of,
fine.
sort of knew, thought I knew where they
I-
were, and we didn't know, right?
Yeah, I'd be stoked to see this in Norbit. That'd be great. It's a pretty large area, though.
That's right. So we may just do this southern. We just got to work. Is there a time that you've been given that, or we're working on the weather, right?
The weather, yeah. So it might move up or back.
But we're talking 3 in the afternoon-ish.
Yeah.
So we'll see when that shows up.
What do you got for us there, Johan?
Yeah, maybe
It's looking
at least
pretty
afternoon.
good. Well, that's, I mean, that looks like midnight tonight is kind of where we hit that threshold, or 6 p.m.
Oh, right. Sorry, yeah.
Dr. Katie just wrote
Got the
in
wrong numbers.
saying there are a few rules for naming vents. One rule is no naming it after yourself, but pets are okay.
What about soup?
What about soup?
Is soup
Someone wrote
allowed?
in Spaghetti Heights as a potential name for a vent.
Oh yeah, I like Spaghetti Heights.
Literally anything is better than dead dog. Just put that out there.
To be fair, Dead Dog, I believe, was a riff on Red Dog, which is a famous fossilized hydrothermal deposit
Okay.
in, I believe, Alaska. But please feel free to fact check me on that.
I'm not trying to hate on this dog. Like, rest in peace, dog.
I'm very partial to the kaiju naming system for our main endeavor field vents.
I like soups, man. I'm on soups. Chowder Hill. Let's keep going.
We're just gonna get hungry.
French
This is what
onion.
always happens. We just start talking about food.
Yeah,
The
this is where we go.
miso
Pizza.
vent.
Yeah.
Miso, nice.
We already have a miso observatory.
Do we?
Yeah, the Marine Institute Scientific Observatory, miso,
Oh.
On the East Coast, right?
on the east of Newfoundland.
Puff the Dragon as a vent name. That's cute.
That's nice. Keep them coming.
So our node is somewhere here.
Johan, our viewer was wondering if you are using
And
the
this is the
Windy app
cork they
for
wanted
weather
to
or
do
something more fancy.
Before, down here.
We do use Windy just for
And here's
kind of
this other venting
forecasting
area,
general
vent hill.
trends, but then we have our own sensors on board
Yeah.
that let us know what we're actually
Well, this-
experiencing, and we
This,
can kind of
I think this is worthwhile
gauge
for
if
us
it
if we're going to lay a
will
cable.
get worse or better based on
So it's
what Windy is saying. But
mandate-wise,
readings
we're doing the right
often
thing,
reflect
even though it's not the most
actual
exciting
sea
thing.
state conditions that are happening very small scale on our ship.
Thanks, Johan.
Oh, no, I forget, how are you nowadays monitoring what's going out on the quad, or out on the, what's that? You have to control 8. Oh, that's new. Ratch, that's the only one I think so. Is that all controlling your fancy new Ross over here? I want to mount it in the desk for him, but he won't let me yet. He's not sure he wants it there. Yeah.
Hey, to the viewer that's wondering about yesterday's dive, we unfortunately did not locate the mooring, but AJ, is the mooring still streaming data?
So the mooring that we put in the southwest is an autonomous mooring, so it logs all of the data to its instruments, and we will collect it when it's finished next year. We can still find it. It has a acoustic release that we can ping with the transponder. So what we'll need to do is sort of drive around with the ship where we can make larger moves when the sub is out of the water and ping it from several locations in order to hone in on its position. And we can make the decision next year whether we want to go back and do a CTD survey of it in order to calibrate the CTDs, or whether we're okay with the data without CTD calibration, in which case we can just release it and find it on the surface. Because we can see, on a clear day out here, we can see hundreds of meters. It's got a beacon on it, so when it hits the surface, it'll send us its GPS position. So it's not lost. We know it's out there. We just never got to it with the ROV.
Yeah, if let's say if we locate it and it's like so far out of the axial valley, maybe we'll not worry about the end timing of the actual. So hopefully next year we'll be placing the core S. If not, I don't know. I think we'll get it next year.
That's the plan, to install core S here next year?
Not here, back at Main Endeavour Field.
Oh, okay, sorry.
So that first Norbit survey we did was basically a lot for that, and,
Cool.
and to get a better, but to find the spots where we can place the two moorings.
Do we think we'll install some instruments here next year, or?
It sounds, right now the
Yeah.
plan is Johan's going to come by with a fancy instrument, and
Oh yeah?
so we've got two.
Oh, yeah.
Are you talking about Middle Valley specifically?
Yeah, I was just curious, because I mean, I know
Oh,
we
here?
don't have anything
None of
here
this is
now.
going in Middle Valley.
No,
Yeah.
That's what he's
okay.
talking about.
Sorry.
What's the timeline? Like, what would be the timeline to get? Sorry if I'm derailing the conversation. You can finish your thought.
10 years,
10 years.
I would imagine, yeah.
Really? Wow. How come?
Because that's how it moves slow. So we have to then now, I wouldn't, maybe not 10. What do you think?
Oh, I have no idea. What are you looking at me for? I don't make these decisions.
Okay, so
This
so
is based on
the
scientific
Neptune,
funding.
so the Neptune Observatory was planned in 2000 and went in, 2009.
Anything
Oh, okay.
you can
But I mean, that was
come up on the winch?
to lay. That was just to do the initial cable lays and things like that, or already getting like devices streaming down there.
I don't think the cable lays were the big deal. It's just getting the money and getting it all sorted out, and then saying, okay, well, we better do a Venus array and a Mars array, and two countries are involved. So maybe this could be quicker. Maybe
I guess, yeah, I was wondering just because like we already have like the
Yeah.
like the the
so it,
ability to connect stuff, right? Because we have like the connection, like the terminal in there.
well, I think P1 is driving it a little bit. So
Oh.
Yeah,
okay.
well, we're looking.
I thought P1 was more at Cascadia.
It is, yeah, but because of P1, we're looking at our mid-life node upgrades or refurbishments, because we
Oh,
may
right.
need to
I heard this,
provide, if
yeah.
P1 is successful in accomplishing its funding goals, then we'll need to provide P1 with more power, which would
Oh, okay.
require a new node build. And then if we're going to be building new nodes, then we may want to test one at Middle Valley where there's
Oh, okay.
um,
Cool.
so
yeah,
you can see the
some
spider web.
availability.
Spider web is growing of all these
Yeah,
little
Yeah,
things
there's
sticking
some.
this
onto
would
it.
take quite a while then. Yeah.
Yeah.
It's just, oh, then the different decisions made. Okay, let's say P1 doesn't get funded or something like that, then different. So
Okay.
I gave you the 10 as
No, I think it's,
closer
just,
to
it's interesting.
0
to,
or 10
Yeah,
or
really-
20.
So
20.
far, like P1 is really seeming to be quite ambitious. Like they have quite a bit of funding, and they're ambitious to try to get more, and it's looking really positive in terms of that project really growing exponentially, which is terrifying and exciting.
Yeah. Well, yeah. It's got to be international. I don't think it can be just a Canadian thing. So
No, of
that's
course
what-
not. A lot of the
And
funds
it's
so
not.
far have come from Europe, and it sounds like there's going to be bids to access U.S. funding as well through partners that we have in the U.S., Michigan State University, Drexel University.
So it's all linked into a lot of things. Not
Yeah.
like, and there's some old plans which people like Katie and Earl Davis and the people who drilled all the like if you go see how many corks are here, quite a few. So we could link up a bunch of those things, and that gives us an idea of how the plates are moving around here. Which so you have a Canadian reason to like. Whatever a public reason to understand this, whereas it's less directly linked if you're trying to talk people into neutrinos, but everybody's we know that understanding neutrinos jumps us a lot in physics. And, you know, it's a great way to, you know, if we can get as good data as we get at IceCube.
Oh, at IceCube, yeah. Potentially better data than IceCube, I don't know. I'm
Where's
not the
IceCube?
neutrino physicist.
That's the problem. Neither am I, so I can't really say.
But from my understanding is the ice creates a very diffuse view compared to water, which is one of the main reasons for moving from the ice
Right.
into the deep ocean.
That's where the other
Neutrino's
neutrino.
a South Pole Neutrino Observatory, funded mostly by the, well, I actually don't know who funds it. It feels very American-led, but then again, like ELISA and all these European colleagues have done a lot of work there, so maybe it's more international.
That makes sense. I mean, there's probably only so many facilities in the world that are researching like this specific thing.
Yeah, and just to like pull it back a little bit, because we got viewers asking what P1 is. P1 stands for the Pacific Ocean Neutrino Experiment, and this is basically a giant observatory to detect neutrinos, and it's proposed to be installed at our Cascadia Basin Observatory site.
And what's a neutrino, Yuko?
Oh my gosh, what isn't a neutrino, AJ?
That's what we're trying to find out. Well, find out more characteristics.
That's exciting.
So
and terrifying, right at the intersection.
Yeah. Do you want to explain what a neutrino is, Steve?
No.
Okay. Here, I'll look up a good explanation. So
I can't do grade 8 neutrino.
That's grade 8. I don't remember learning about that.
I did not learn about neutrinos.
No, I think we're.
That's your Nova Scotia education, very advanced.
So a neutrino is a particle. So while electrons have a negative charge, neutrinos have no charge at all, and they're very small. And the reason why we're putting a neutrino telescope in the deep ocean is because when they, I believe, interact with water molecules, they let out a flash of light that can be detected in the very deep ocean since it's so dark and quiet there. There's also a neutrino telescope in the South Pole, you said?
South Pole, yeah.
Yeah, in the South Pole. That one's called IceCube.
Yeah.
I don't know if you want to speak.
And of course, the one that we're basing it on is in the Mediterranean. It's called
KM3net.
KM3net.
Where is that one in the Mediterranean? Is it in the ocean? Is it on land?
So we just
It's
got
in the
Mediterranean
Sea.
Sea, yeah.
Okay.
And I guess it's near, where is it, like Italy?
I think it's south of France.
So yeah, near Italy.
Yeah.
So
well, I
yeah,
guess it depends what
it's
side
all
or Spain.
it's near Algeria.
Oh, okay.
Greece?
I don't know. It's
Somewhere in the
fairly deep.
Mediterranean Sea.
So it's like
It is deep, yeah.
So it's got to be in the middle. So you're kind of like near to all the places that are on the Mediterranean. No, I think it seems to be off of France towards Italy. How's that?
The
And
Calypso Deep is the deepest point in the Mediterranean Sea.
And how deep
We
is
can
that?
look this up, so we're not getting it wrong.
Yeah, just get it right.
5,100 meters.
Yeah, so it's ridiculously deep.
That's in the Hellenic Trench and the Ionian Sea.
And so what's happening there? There's a spreading center between that and Europe and North Africa. So it's all kinds of same stuff that's happening here.
Cool.
There you go.
Hey, did you guys just see that?
See what?
100 million neutrinos just passed right through Atalanta.
Whoa.
They just went through me.
So that
to you next.
interesting light
Got
that you
him.
see is the same thing if you ever seen pictures of radioactive tubes in a nuclear power plant giving off that real weird blue glow.
Cherenkov light?
Cherenkov.
Cherenkov?
Cherenkov. Yeah.
Oh.
Yeah, and so The neutrino telescope will be
Sicily, Italy.
installed at the Cascadia Basin site because ONC
France.
already
You're
has
both right.
infrastructure built at Cascadia Basin to help us
A
to
map would
monitor the
help, but
experiment.
I've never seen one.
This is where'd you study?
The deepest spot, no, I'm saying the
Oh.
deepest spot was offshore of Pylos.
Oh, yeah.
Yeah. Sorry, you go.
Yeah, no worries. I was just answering a quick question that came into the question box about
Cherenkov.
would deeper water be better
For the experiment?
for the experiment, but it's going to be at Cascadia Basin because we already have infrastructure there to support the experiment.
Yeah, Cascadia is also our deepest site. It's very deep, and it's very flat.
Yes.
Without a lot of, I mean, I'm not sure how the bioluminescence compares to other places, but it's definitely not as productive.
Sorry, you're talking about Steve?
Yeah.
as
There
Barclay.
you got it. That it's got a good.
And
Thanks,
so
Grant.
I think you want less productive areas because bioluminescence is one of the main noise signals for these detectors. So there's a lot of reasons that factored into its placement, its proposed placement in Cascadia Basin.
Yeah.
And we've done 2 Pathfinder projects with the people at the Technical University of Munich called Straw A and Straw B for string absorption length in water. And those were projects that were set out to determine the feasibility of the water properties at Cascadia Basin for this type of neutrino experiment. And so you can find more information about that on our website, I'm sure, and on Technical University of Munich's webpage. And hopefully the data that they got from that was really helpful in securing funds to move this project forward.
Yeah, and we do have, if you're interested in learning more about that, on oceannetworks.ca, if you go to, I believe it's stories in the main menu. I'm just taking a look right now. We write all of the updates to these projects, and it's available for you to explore on our website.
Besides the neutrino detector, what other new instruments are you guys cooking up back in the lab there?
You're very quiet there.
I can't
Oh,
hear
I
you
said
either.
besides the neutrino detector, what other new instruments are you guys cooking up back in the laboratory? The mad science laboratory.
Cooking up, eh? Well, the CORAS experiment. We also have a
Johan could
in the
explain.
works.
Johan could explain the distributed temperature sensing.
Yeah,
because
I think
that's
Johan should explain
we're
that.
cooking that. We're not really cooking at all.
Johan's cooking in.
He's cooking over there.
Yeah.
So,
Johan's kitchen.
what? Let's
like
let's
the
get
new
out of these
Netflix show.
neutrinos. We're an ocean observatory, not a deep space observatory at this
Why
point.
can't we be both, Steve?
We are. We will be, but we're not yet. We
Is
don't have
the-
our deep space
The distributed
expertise yet.
temperature sensor,
On the
is that
back deck here, anyway.
Is that the fiber optic? The
Yeah.
long line fiber optic?
Yeah, so it's essentially if you send a laser pulse of light down an optical fiber and you look at some specific wavelengths that are scattered back towards your source, using that information, you can calculate temperature, and then using the timing that those photons were received, you can calculate how far along the fiber that temperature is. And so it effectively allows you to measure temperature along the optical fiber, and you can bin that into discrete measurement sections and use a narrow, pretty flexible, and a lot more compact and easy to manage fiber as the equivalent of an array of temperature probes. So it can do that on up to a 10-kilometer fiber.
10 kilometers.
So
What's the limit in length? Like, why 10 kilometers?
I think
Tech.
Signal
the
just
strength,
degrades?
yeah, noise to sound to noise ratio.
It's
Signal to noise.
amazing how quick that tech is taken off. I went to what they call Suds in Science talk at OSU a couple of years ago, and they were had a contraption go, and they were doing that with fibers on weather balloons around for doing microclimate, like around all the vineyards and the farms around there to see how the air moved through the vineyards and where it was hot and where it was cold.
Yeah.
And then there was some scientists at UH that were doing the same thing subsea. Last year, they were deploying something off of one of the nodes there that UH has, doing temperature experiments. I always thought, so would it be possible to do that, like, for example, with one of the spare fibers running down the umbilical, or does that fiber have to be
Yeah, I mean, you
special?
have all those layers around the umbilical, so your temperature, your response to change would be probably slower, but if you're sitting with your cable in the water for how long we're doing a dive, it would probably, the water column's not changing too much.
Would you have to like calibrate it to some reference temperature or something, if a different type of...
That's how we do it, yeah.
How would that, I mean, could you then validate that against the CTD data when Herc is diving, kind of? Like, would that be a good validation case for, because you're getting a CTD profile essentially, and then the tether is sitting in that water?
Yeah. How it's usually done is you have like a designated section, so 10 or 50 meters or something spooled up right near the CTD, which we could also do, just spool up well, I guess maybe not through the umbilical, but in theory, have that right next to the CTD so that you have a long section and a few points that you can calibrate directly to a known temperature source or temperature measurement.
So in the case of ONC, that will there eventually be a fiber in a mooring? Like, is that where they're going with
that? So through my PhD, I've kind of taken a commercial DTS that's used for topside land DTS measurements, and we've broken it down into a pressure housing.
What's a DTS?
A distributed temperature sensor. Broken it down into a pressure housing, so it's a subsea in situ unit now. And we are still figuring out the exact science project we want to do with it at ONC. But we've talked about kind of laying it around the main endeavor field.
On the seabed.
In some kind of format, but up a mooring would be pretty interesting. That's something that our lab is doing separately, I think, in the near future. And yeah.
So the one you're cooking up, you're talking about laying it down on the seabed.
Sorry, you're very quiet again, Dan.
The one you're talking about laying it on the seabed, so you would get measurements. It would lay out like an oily cable.
Yeah, that's what we've been talking about so far. Either, so I don't know if you remember the kind of layout of the main endeavor field, but right now we have it set up to work on 2 fibers sequentially, so it'll measure on one for a minute and then the next one for a minute and just keep alternating. And we've been talking about spreading one of those up to the north to be near Grotto and all the vents that are up that way, and then one trailing down towards the south and reaching the southern section of the vent field as well, and kind of seeing if we can observe this shift in heat over time to the northern direction that the main endeavor field has been experiencing.
And the big thing is how to couple the actual fibers with the seafloor itself over that incredibly craggy or rugose.
Is that a word?
I don't know.
It is now.
Rennie used it.
What is it? Say it again.
Rugose?
Rugose.
I feel like I've heard that.
I'm...
Like
it means
it's a rugosity.
wrinkled or corrugated.
Wow, what a great word.
An example is rugose corals.
Ah. Also, we've got a sea cucumber in the Herc cam.
Oh,
Yeah.
nice.
Very,
Just
very
drifting.
slowly drifting.
Yeah.
Kind of rugose.
So is there a grade 8 explanation from the difference between distributed
grade 8?
acoustic sensing and distributed temperature sensing, or basically explaining what Raman backscatter is?
And just for the listeners from the US, that's 8th grade we're talking about.
Is there a simple way to do that one? I don't know if there is.
Essentially, DTS, distributed temperature sensing, looks at Raman backscattering, which is essentially as the light propagates forward in the pulse of light that you send through the fiber, it interacts with the glass particles and is absorbed and readmitted. And depending on the temperature or like excited state of that molecule of glass, the probability of it being emitted at one wavelength versus another is kind of a known ratio. And so then looking at two specific wavelengths that come back, one that has a higher probability of being formed at high temperatures and one that is pretty temperature independent. You get temperature through that with a few other factors about the fiber and your laser and all that. Distributed acoustic sensing relies on something else, essentially.
I think it's the impedance change along the...
Yeah, it's the strain along the fiber, essentially.
So I hear that word a lot nowadays, Raman. We hear it on the Mars rover, and we had a Raman laser out here. And every time I hear it, I associate noodles with it. What's going on with that whole mumbo jumbo?
It's a guy's name.
It work?
It's a last name. But maybe there might be more than one ramen, because there's so many ramen things out there. It's amazing.
They really are, yeah.
Very
A lot of flavors.
right, yeah. But why don't we look poor old Ramen up, see if he's one guy or is actually like a
Good luck
big,
finding this kid.
big.
It's always food, right?
It always comes
They
back
always
to
have to have food names.
Okay, there's an actor.
Oh, just and I like
Music
that we're
composer.
using the grade 8 level, because the grade 8 reading and writing level is the accessibility standard for a lot of the things that we do at Ocean Networks.
Okay.
Yeah, so anything that we put
That's
out
cool.
that's written is written at a grade 8 reading level, essentially.
That's cool.
We're trying to push it a little
That's
bit
why I
higher.
always struggle.
Get it to grade 9 or something, maybe.
It's a little too
I definitely make sure Nico writes our dive plans at grade 8 level so that I can follow them.
It's a very accessible grade level.
That's great. Accessibility is so important.
Yeah, we're working towards a lot of that, meeting those standards.
Well, I think we should raise the standard of the grade 8. That's what I would...
No, because I dropped out of school in 9th grade and I started working offshore. I've been here ever since. You guys got to keep it, on my level so I know what the heck's going on.
It's just for you, Dan, just for you.
Thank you. Makes my job easier.
How's the search for ramen?
Yeah, it was Sir Chandrasekhara Venkata Raman was an Indian physicist known for his work in the field of light scattering. Using a spectrograph that he developed, he and his student K.S. Krishnan discovered that when light traverses a transparent material, the deflected light does something, and I just lost it.
I wonder how he felt about instant noodles.
Yeah, I bet you. I wonder where that ramen came from.
Well, ramen is a
Japanese,
Japanese cuisine, I guess.
Is it just like the Japanese word for noodles?
Oh, I think it's a specific type of noodle. It's the way that it's made.
Doing it.
I see.
And then you also have udon as well, which is another type of noodle.
And soba?
And soba.
We could name vents after noodles.
Oh, that'd be so cool. All the worms look like noodles anyways.
Now I want
Face
ramen.
Jake.
Dan, can I grab those photos from you later? It'll be nice to have in our catalog.
Wait, what happened? Did you get distracted, Jake?
No. Things are going great.
You know, when people say that, things are often not going great. Should we be worried?
No, things are great.
Okay, coming from Johan, I feel like way more reassured.
Yeah, Johan's voice is very reassuring.
In
It
Johan
is.
we trust.
In Johan we trust.
Not so much Jake, but that's okay.
Oh,
What's that?
I said not so much Jake, but I'm joking.
Wait, same person or?
Two sides.
Just
to the
kidding.
coin, yeah.
The mapping looks so cool.
Yeah, it's a nice flat plane.
So what's the ideal depth to be from the bottom when you're mapping like this?
it depends on what resolution you want, and then how wide you want your swath width to be. And for something like this, we want kind of a bigger range, so we're about 30 meters off the bottom. But if we wanted to do some a little more higher resolution stuff, we'd get in a little bit closer. Maybe anywhere from 10 to 20 meters.
Makes sense.
Yeah.
How wide is the swath right now?
I want to say like
About 100 meters.
100, yeah.
Okay, that's pretty good.
Yeah. All right.
You can work that out in your head. We're 30 meters up and the beam width is 160.
Yeah, 160, yeah.
Jake can work it out in his head. I need an app
You can
for
put
it.
the,
It's like almost 200.
oh, is the measuring tool working?
Yeah, it gives a little...
It was crashing the program the other day.
Yeah, well, I'll stop.
Yeah, please don't crash the Norbit mid-survey.
It just crashes the visualizing tool, not the
Yeah.
actual Norbit or the recording.
Okay, good.
Is there any chance that we can screen record this for us to use for as a communications asset?
1 second, let me see.
Does ONC get the quad as a deliverable?
No, I've never seen the quad.
Which is Herc and Atalanta cam. Apparently we get deck cam too.
The deck cam's not recorded. Is
I
it?
thought Greg said that there is the opportunity to dig up deck cam footage when it's on. Oh, maybe only when it switches over
Yeah.
when
Yeah,
Herc's out of the
maybe.
water. I see.
Yeah.
We
Yeah,
for sure get the Herc cam. I don't know
What's
about
what's on
Atalanta.
we get everything that's on the ONC website. So what does ONC website have?
The Herc cam.
Yeah.
Zeus.
No deck cam.
Only when Herc's out of the water.
Yeah.
Right.
Yeah.
So we get all that.
Right. Okay,
But
but we're
we're
not
not-
getting, we don't get the quad, so we're not getting the Norbit.
We're
No.
not like setting that up on C-Tube.
No.
Like
No,
what
no,
we
no.
show is, yeah, the Herc and
No,
Atalanta.
but I think we do have it somewhere.
Yeah.
Because
I've
I was going to
never-
ask.
I work with Greg to like ingest that data after we get it, which is usually like a few months after. And we've, as far as I know, like we've only ever worked with Atalanta and Herc. I don't know about any, or like I don't know if we've ever
It's automatically
bothered.
ingested as it comes. It's being ingested right now. I can go back and get it.
Yeah, but that's like the satellite feed. But I mean like the high res and the
Right.
full res.
But that's all we're
Yeah.
basically talking low
Right.
res, whatever.
Yeah, I don't know that we get the high res.
All you got to do is go on YouTube. It's there for
That's when it gets ugly. The high res. It's
Yeah,
just
it's a lot of work,
Yeah.
and
Is it-
Greg is a wizard to get it all done. Truly.
Is the YouTube feed, like, does it record all the history? Can you go back through the YouTube channel and see
Yeah.
like all
I
of
think it has the app on
Nautilus's
what you just said is recorded forever.
on YouTube?
Yeah.
Yeah, they have the
Wow.
full
There.
dive.
I'm a YouTuber.
recorder.
You're a tuber?
You're a
I'm
tuber?
a YouTuber, apparently.
Do people say that, tuber?
No, no one says tuber.
That's a
I'm
root.
clearly
It's
not
a
a
root
YouTuber.
vegetable.
Which tuber are you?
tube.
Take the quiz now.
I'm not a YouTuber, in case it's not obvious.
You are now. So what's our ETA now?
About 1 more hour.
Oh, man, really?
We're crawling through the water right now.
You can't be the one who's shocked by this. This is your dive.
Well, my calculation was 0.3 knots. What's that? 0.3 knots is
0.6 meters a second.
10 meters a minute.
Oh, no.
10 meters a minute, and we have
0.15.
1,000 meters to go. That's easy math.
700 meters to go.
700 meters to go, sorry.
About an hour.
That's an
Because
hour.
I'm
this
personally
ain't
enjoying
getting
this.
us anything. It's flat.
Correct, yeah, it's flat.
Oh, a great job on
We
Atalanta.
might
Thank you
be
so
about
much.
to
I'm
go
working
over
really hard
something.
over here.
Pretty much. It's been flat.
Don't
We
speed it up
could,
too much.
She's holding
Go.
back. She's
Good.
doing her best.
Great.
There's a possibility, Steve, of speeding
up.
the whole mess up to 0.5, but I would not recommend it, given
Because-
given the wind speed and the noise that the bow thruster is making right now downstairs. Everything is working right now, so we
Yeah,
change.
the problem is the more interesting stuff is on the other end, and we're gonna burn up our time.
Roger.
That's-
But you could wind up taking more time, so if the vessel comes off the line, then we lose the line.
Do we have a deadline
all
to
the ducks
recover?
are in a perfect row right now. I would.
Yeah, you
I'd
feel
take
it in
the time
your
hit.
seat. If you start moving more, it's weather dependent.
Yeah, that's what I mean. Are we is there a time when the weather's really coming in and we have to?
No, it's
I
actually.
feel it moving more now
Yeah,
than when I first got here.
It's coming up all the time. So, and the wind. What's
That's
the
what's
wind
scaring
right now,
me.
Johan?
We're reading like 17 knots.
Yeah.
From the north.
214.
So it'd be a big shame if we got a nice flat piece of Norbit, nothing bumpy.
Yeah, well, so we can risk it and increase the ship speed, but then if the ship comes off and we don't get the Norbit for this,
Roger. I would
for the
advise
second,
to let it ride for an hour.
or we get a nice Norbit and risk losing tasks on the back end. These are our decisions.
Yeah. You're not going to gain that much. The difference between 0.3 and 0.5 is
Yeah, 40 minutes versus an hour.
right, and the risk of the ship coming off the line is.
You're saying this is interesting stuff, maybe, potentially?
I don't know. I mean, it's 60-meter resolution.
60-meter resolution
So
squares.
it's
I'm going to put my money on that one right there.
this one's cool.
Yeah, that one's cool.
All right.
Oh, I was looking at the compass there. I need
Ah.
a compass to.
Yeah.
Even after all these years, when someone says 214, I got to look at a compass. More like, northeast, southwest.
Southwest. Yeah.
Southwest, thank you.
A viewer wants to know if the data gets fuzzy on the Norbit at the widest parts. Not quite sure what they mean by the widest parts, but I was wondering if it gets fuzzy towards the edges of its range.
Short answer is yes. Yeah, you can see there's a lot more noise out there because the sound is traveling so much further.
Your signal-to-noise ratio decreases.
Yeah.
Get further out.
When Rennie processes it, he'll probably edit a lot of the edges out. So
Yeah.
even though with a
Prune all his points.
yeah,
Got it. Okay, so the noise gets pruned.
yeah. So even though the Norbit is set for 120 or 160 beam width,
Yeah.
Effectively he'll probably use like 120.
Okay.
which gives you that 100-meter swath according to my app. 50 meters each side. We have picked up things like way out there, over 100 meters. But we were playing with, actively playing with the settings of the Norbit. And you can also twist the beam angle of it.
Yeah.
So it's not looking, like right now it's looking straight down.
Oh, so you can angle it, like kind of look to the side.
You can indeed angle
Yeah.
it till it looks to the side. But depending on where it's mounted on the vehicle, it'll start hitting the jewelry hanging down on the vehicle, the bumper and the lights and stuff. But so we've had that Norbit mounted in, this is probably the 4th or 5th position we've had it mounted in. And we have to take into account, you know, the manipulator hitting it for one, it hanging down too low to obscure the visibility from the other cameras, sticking out too far in the front. You know, when we push up against structure, you can see like when we land, a lot of times we're touching the TIE fighter or the antlers there, or the brow as we call it. So if it's sticking out too far forward or too far up, it'll get physically damaged when we park Herc on a vertical structure.
Johan, what are you looking at over there?
I'm trying to point out all the things that Dan's talking about
Oh, cool.
on the
So
vehicle.
yeah,
Nice.
you can actually see if Johan zooms in where Norbit is mounted there. It's
Just on the, right on the brow there.
Yeah, yeah.
Very close.
there's a bunch of text around that that gives it a what's the word I want?
Still got the old manifolds on that model.
How do I get to side chat here, or these messages?
No, these are messages from the question box.
Yeah, how do I get to it? Could you?
It's
www.
No, I just want to look at the messages on here.
It's not really for that, Steve.
But I can answer them then.
The easiest way, Steve, is to pull up that computer using the KVM in front of you there.
Well, I was just trying to communicate with Katie when we get to there, and she's on that. Okay.
External stakeholders. Yeah, the external stakeholders chat.
She's not chiming in there. She's talking to side chat or that. But I can answer her if I see what her. Okay.
The correct channel would be the external stakeholders chat, not the Nautilus Live text in.
Yeah, whatever you do, don't hush up.
play.
We use it. You can lock out certain functions so that like only like the wrist moves or the jaw, or so you can kind of learn how the arm works one function at a time. The best.
Anna, you see that blue LED light on there? You see the button right next to the blue LED light? Press that button and see what happens. Okay, now you can press any other button except for that one.
Yeah, you can hold the arm and
fill
stuff
your
too.
boots. Just don't change any of the...
I can hold it?
Yeah, you can hold it, move it around. It's not activated. Hydraulics.
Dude.
What you did there, yeah, you disactivated the live hydraulics to the arm, so it won't move.
Should I not activate it?
Not unless you want to poke Jake's eye out with it.
I mean, I don't want to poke Jake's eye out. He needs that. All right, I'll not do it.
No, you can play around with it now as long as the hydraulics aren't on. It won't do anything.
Yeah,
so that blue button.
I typically hold it like you want to have like some like a control of the elbow with one hand and then the wrist with the other, and you try to like have a grip on. I don't know. I kind of tend to go like this.
Here, you show me.
Yeah. So I put my thumb like on the continuous here, so I can also hit these buttons here, and then I'll use like my pointer finger to do the jaw.
Cool. Nice.
If you poke some buttons on the screen in front of you there, you can get to what they call display pots in the controller that's in your hand.
How about test?
Yeah, that's probably a good place to start.
Okay.
And at some point in there, it'll show you some numbers when you move the controller around.
That will show you the value, like as you moved different functions, the master values should change.
This is cool.
Yeah, you can see like when you go from one range of the limit to the other range, the value should go from like, you know, a low number to a high number.
Yeah.
And then it'll get to like the extent of its range.
Cool.
So one of the challenges to operating that thing is to hold it and move it in such a fashion where you can see the numbers changing in a linear fashion. If they're changing rapidly, if the slave arm was live,
Paging
or the manipulator
Dr.
was live,
Katie
it would be doing the same thing, spazzing out.
on SPL. You should receive an invite to our external stakeholders chat.
So basically just like
on Google,
slow.
Steve Adder.
Just move it
So
gently.
please join that, and then we would love to have your feedback available to us when we reach the hydrothermal vents.
We use that screen that you're on now to actually test the functionality of the controller that you're holding. So there's feedback, obviously, in all of the joints of it. So if they don't track in a linear fashion, that's noise, which is then
Sweet.
picked up by the
Hold on.
manipulator.
Wait 1 sec.
What? Nothing.
Yeah, we typically discourage that in the front row. It just takes you completely out of the room, and in the time that you're doing that, something bad is going to happen.
Well, this is very cool, and if there's ever any time to kind of check it out, that would be cool, but you know.
Yeah, unfortunately we can't right now, because if we move the arm out, it'll deflect the Norbit beams. So everything has to be tucked in for the Norbit survey.
For sure.
Otherwise we'd let you have a go with it.
Yeah, we'll have some time in during ascent or descent during one of our dives.
Nice. Sadly, I only have 16 minutes left of shift, but... I mean... yeah, it's tempting.
I can see, still see the depth oscillation there in the...
Yeah, I tweaked with it for like half an hour.
Yeah,
Could not get it better than this.
and you're back to the where you were on the...
Just about. I had it like, or I modified it a little tiny bit.
One of the things Robert plays with is the velocity command on the Auto XY page. He, I'm not sure what it is right now. He softens that up a little. I think we did at the start, but what is it right now?
I just changed it, but it's 0.25.
The max velocity?
Yeah. Z.
Yeah. So that's...
Seems like it might have smoothed it out a little bit.
Yeah, it'll just do longer oscillations.
Which is better.
That means it's trying less hard, but yeah, it totally smooths it out. So one of the gotchas, Robert will sit down there and he'll soften it all up so you get really smooth video.
Yep.
But then it won't have enough authority at the end when it starts, like the bathymetry starts increasing or decreasing.
Yeah, it's like a
And
delayed.
Yeah, it'll plow itself right into the seabed. I've done it several times. I'll sit down there after it's all softened up, and then we'll start going uphill and not paying attention and just completely bury support. Yeah, it looks way better.
Yeah, I just lowered it even more.
So 0.25 it is. At some point it'll drift farther, but not as fast. So it was 1 and you made it 0.25 and now it's...
It was 0.5, I made it 0.25. And I just lowered it to 0.1. I'm going to see if it gets worse or better.
Roger. It's worth capturing all this and then maybe...
Yeah, we could have a Norbit standard.
Yeah, maybe we do a README or some notes there on the Norbit machine.
Put a little README on the...
Yeah, then the navigators...
Add it to the navigator's Norbit, whatever, SOP.
Yeah, because those values will all get, you know, depending on the operator sitting up there, they'll get changed. It'll be nice to have a baseline to start out with, which we don't have yet. I think part of that SOP, if we're still writing it up, is like what we're doing now. So having the ship and Atalanta and Hercules all in a straight line. I noticed the other day they were doing it. They were a significant offset with Atalanta, and it was, you know, pulling the heading around. Sometimes you can't help it, but... Do you have any Z-bias in, Jake?
I do.
I don't, so it's not clear to me how that affects the auto altitude. It shouldn't, in theory.
It's hard to tell without actually looking under the hood and seeing what's going on.
I've tried to work it out empirically a few times.
I don't know, it kind of seems like the more you dial it in with Z-bias, the easier it is for the PID.
While it's in auto altitude.
Yeah, I think you can do it while it's in auto altitude. I don't think it will.
I kind of think it completely ignores Z-bias, because I think one time I, cranked it way in so it was totally obvious, and then obviously when you put in select auto altitude, it stops that.
Yeah, it might. I'm not sure.
Yeah. That looks pretty good there. What's that value?
That's 0.1 to max Z velocity.
Huh.
Yeah, that's pretty good. I'm writing some notes.
Awesome. This this whole business is still kind of in development as well, so trying to get Herc to behave nicely to get good multi-beam data. A lot of the multi-beam data we've done to date has been with Atalanta static and Herc just, doing a small area on its tether. Or it's been a kind of a gross one as we come down, the side of a seamount. We're taking orbit data just to get a rough map, so we turn around and go back up. But I don't know if we've done any long transect deliverables yet. What'd you turn on and off there, Johan, the voxels? I thought they, so it remembers the voxel history when you turn them on and off, the octomap cubes?
Yeah.
Huh. I did that the other day and I thought it forgot them after maybe I turned on and off points or something. Well, that's probably a good one to know. There's a setting in there somewhere that says what that buffer is, isn't there? Why is TF yelling at you? Or is that just an icon for it? It's got an exclamation point up at the top. TF has an exclamation point. Is there something in there that's not happy? Right above the flashing odometry one? Or is that just the icon for it?
Oh, I see what's going on here.
Warning. Hercules is about to implode. Gives you a message down at the bottom. You click on one of those, a little message will pop up in the box down below. I'm gonna slide the bar up a little. That bar right there. Oh, it's this UTM. Maybe that's KTM or K2's wishful thinking that he had a INS on there.
An INS, yes. That's his dream.
Or is that a reference from that it's not getting UTMs from something? Yeah, I don't know. It's probably worth noting. Don't know if it's good or bad. Just a warning, so.
Yeah, I might do. He hasn't been using the Nautilus model because it uses up a lot of resources. I don't know if that has
Oh,
to do with it.
is that what it is?
I don't know. I'm not sure.
Yeah, probably. We're trying to get him to get the Atlanta model in there. Totally. He had the ship in there because that was easy. He could get the data from it. But like Jake says, it used a lot of resources. And it was kind of a dud because it's like, 2 kilometers away. I'm going to step out for a minute, Jake, and I'll come back and relieve you. I'll have to find another victim to sit in the Atalanta chair.
Ashley's coming in like 5 minutes, so yeah.
Maybe you can convince her to sit there.
I think she'd be into it.
Why did the multi-beam sonar became a comedian?
Oh, why, Yuko?
Because it had a lot of depth in its jokes.
Hey,
that was, cannot take credit for that. That was someone, a viewer in
Canadians
our
got depth?
questions.
Is that what they're saying?
No, the joke was, why did the multi-beam sonar became a comedian?
Oh, a comedian. I heard
A
Canadian.
Canadian.
I was like, we got depth?
No, we're just surface level. Thanks for that giggle, viewer.
Sorry I
jokes to
groaned
keep us
at
going.
it. It really amused me. I love bad
Anna
jokes.
groaned at it because she thought it came from me.
I loved it.
Well, I don't think they're going to feel very genuine about that.
Yeah, just a quick overview of what we're doing and where we're at. We are currently diving near the Endeavour hydrothermal vents. We're at a site called Middle Valley. And we just finished when I say just, I mean like maybe an hour ago. We surveyed a trawl-resistant frame that goes around our node. At this site, we actually don't have any instruments here yet, but we do have some infrastructure set up for future installations. So now we are transiting over to Middle Valley from the node, from the trawl-resistant frame. And along the way, we are using the multi-beam sonar that we refer to as Norbit on Hercules to map the path. So far, it is a very nice, beautiful, flat sea floor. And when we get to Middle Valley, we'll take a look at the Dead Dog vent and also visit the Chowder Hill vents as well. And at these vent sites, we are going to be taking temperature measurements as well as gas type samples. So I think we have maybe around, I want to say 40-ish minutes left of our transit. This is a pretty slow process because we want to get beautiful data with the multi-beam sonar. And just so everyone knows, we are coming up to shift change, so there will be a bit of shuffling happening in the control van.
Okay. 2 more minutes.
And to the viewer wondering what the Norbit is and does, Norbit is the manufacturer of this particular multi-beam sonar that is mounted on the brow of the ROV Hercules. And how I understand the multi-beam sonar is it sends sound pings to the seafloor, and the pings reflect back from the surface and gets sent back to the multi-beam sonar, and that's how we can get a beautiful map.
What do the sound pings sound like?
I don't know, Dan. Could you, would you mind making the sound so we can hear it?
And that would be embarrassing.
What does the sound like? I think this is a YouTube dive.
Is it anything like the sound of the multi-beam that comes from the ship when we're doing ship or mapping from the ship? Maybe? Kind of like a little chirp?
Yeah, I reckon.
Is it a chirp or a ping? Those are two very...
What does that sound like?
Oh, yeah. AJ, what does that sound like?
I've never heard the multi-beam.
Oh.
The multi-beam, to me, the first time I heard it, sounded like a smoke detector with a low battery.
Yeah.
And the first time I was on a ship that was doing multi-beam, I thought that's what it was. And I was looking around for the smoke detector with the battery that needed to be changed in the middle of the night. And the steward found me and laughed at me. So, but yeah.
Good morning, Lynette.
Someone is
Is Ashley going to have to do, Ashley and Monica are doing push-ups?
What?
What? Oh.
Yeah, if you're late for your shift, you got to do push-ups.
One push-up for every second.
Every second?
They're up at 70 push-ups.
Oh.
Every second. I covered an hour of Cassie's shift yesterday.
That's 3,600
She has a
push-ups.
real feat of strength. JK. Sometimes it's worth it, you know, to get jacked. Yeah. Show up late.
Get that extra sleep in and then you get big.
Exactly. It's like,
Lynette's going to start being late for her shift.
Yeah.
As an excuse to go to exercise more.
it's just like win-win-win. Depends how you look at it.
Oh.
I would call it a lose-lose-lose.
Lynette, I don't really get a lot of time with you in the control van.
What's up?
I overheard in the mess hall what sport you played, lumberjack sports. Is that correct, or is this fake news?
That's real news.
That is so cool. And then I also heard something about chainmail socks.
Yeah. When we do the chopping events, we have very big, very heavy, very sharp axes, and you don't want to cut your toesy woesies off. So we wear chainmail socks.
That is amazing. Are they like super heavy?
They're not super heavy, but they definitely have some weight to them. And mine like go up to my knees, so they're kind of big. And every time I fly with them, I get my bag searched.
That's kind of amazing. And what kind of shoes do you wear over those?
I just wear like a really thin-soled, like it's like a kung fu shoe.
Oh yeah.
Like flexible, thin-soled.
Yeah, almost like slipper-like sneakers.
Yeah.
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 Hang on, I was tuned out for a bit. What is this? Something that goes on your feet? What are we talking about?
Oh, chainmail socks.
Chainmail socks.
Yeah. Do you not know about Lynette's competing?
No.
Lynette is super cool, AJ.
Well, like I know that you do lumberjack stuff.
Lumberjack stuff. Yeah, and when we do the chopping events, we wear chainmail socks so
So you don't chop your foot.
you don't chop your foot.
Have you ever come close to chopping your foot?
I have slices in my shoes,
Oh
but
my
I've never
gosh.
actually hit my foot.
That's
So it's
scary.
like just skimmed like the rubber of my shoe.
Wow.
Wow.
Yeah.
How long have you been doing that?
I started with like the chopping and sawing stuff in 2017.
Wow.
So, yeah.
How does one get into that?
If
you don't mind sharing.
Yeah, I sort of grew up going to some of the events as like a spectator. So I'm from northern Wisconsin, and there's a huge event there every year, the Lumberjack World Championships. So I went to that as a spectator a lot as a kid, and I thought it was super, super cool.
Cool.
And then when I was in college, for undergrad, I started log rolling a little bit. So that's when there's a log in the water and you are standing on it and you have a opponent also standing on it and you're rolling the log essentially, trying to stay balanced yourself but make your opponent lose their balance and fall off into the water. And then when I started grad school in New Hampshire, that university actually had a lumberjack club.
Oh, cool.
And so I joined that and started doing the chopping and sawing as well.
Do your parents, or do you have like a wood stove at home that requires a lot of chopping of firewood?
Yeah, so my parents heated their house entirely with firewood. So like every summer vacation.
They must be stoked that you've taken this up as a hobby.
Yeah, like every summer vacation from school, we had to cut and haul like 10 wheelbarrow loads of firewood before we could go and play with our
Good
friends.
Like a half a cord or
going?
something?
Good, how you doing?
Good.
Yeah, maybe.
I don't know how much a cord is.
Anna give you the lowdown on
Something like that.
A little
what
bit.
buttons to press over
How
there?
do you control the angle again?
Yeah, I'll give you the walkthrough here real quick. So I'm on the same page here as you are. You look at my screen.
Uh-huh.
So right now Atlanta has auto heading engaged, which we want, and then on to the left of that you see -1 and -10
okay.
degrees, and to the right +1 and +10. And so if you, for example, click the -10 once, it will change the little yellow dot you see here to the left of the compass. That would be the new auto set point, so I'll just do it once. You'll see the dot change. And now that's going to be the new set heading. The other control you have here is the winch. So when you deflect this lever, you see that bottom left corner there, the winch moving. And this number right here is what we call our delta. So that's the difference in altitude or depth of Atlanta versus Hercules. So I'm decreasing that delta right now down to 15, some less number because we're getting some separation now between Hercules is actually right here where all these USBL dots are. So I've given Hercules a command to come to the south a little. So right now the computer's flying Hercules in what we call auto XY. So it's basically flying off the DVL. But it's the DVL and the USBL drift. So where it really is up here where these blue dots are, where the USBL pings are. But we can't recenter it right now, otherwise the computer would then rapidly drive Hercules off the line. So I've told it to step to the port a little while it's moving forward. So in theory it should bring it back in front of you.
Gotcha.
So by lowering that basically we have a fixed tether between Atalanta and Hercules, right? 30 meters, somewhere in there. So we kind of manage that by the height and the separation.
Because
So
right now Atalanta's to south, right? Right?
yeah, Atalanta is pretty much directly south, so I slowed my forward velocity down a little, which I'm controlling here.
Okay.
So I'm gonna, if I just click that number, I'm gonna enter a new number and speed it up a little bit again. But I didn't notice we're a bit out of the box there. Ideally, we want Atalanta and Hercules in front of Atalanta, so we're not dragging the tether through the water sideways.
Yep.
Because when that happens, that tug on Hercules' tail basically skews our heading, so our heading wanders around a little, which affects the multi-beam data.
So how would I correct Atalanta?
So if you want to stay looking at Hercules, you would just click in, for example, 10 degrees to the right, and that'll change Atalanta's heading. Yeah, I reckon. But we're still an hour away from that, aren't we? Roger. So I'm playing with, you can see the step on the nav screen where I stepped Hercules to the south a bit there. I'm going to give it one more because it's obviously drifting off to the north still. And I got to slow my speed down again. Ooh, I got way faster. I put 0.15 instead of 0.5. Actually, I'm going to hold position for a minute and I'll let it catch up. So we do not want to reset the DVL, obviously, because we're in auto XY. Some other things you're keeping an eye on over there. Yeah, the main ones for you are the delta, which you control with the winch, and the heading of Atalanta, and the camera angle, which is this one over here, which is kind of wonky, the controls of it. You can play with it a little to figure out how it works. But basically you're trying to keep Hercules in the center of the box.
Cool. What's a DEG?
Where do you see that?
All right.
Oh, HDG?
The 1+1 DEG.
Degrees.
Okay.
So those are in, yeah, compass degrees.
Gotcha.
Ideally, if we were all tracking in a line, you see these red bars right here that are fluctuating.
Yep.
So that's Atalanta fighting to maintain its heading, but because it's kind of going through the water sideways a little and getting drag from the tether, it's struggling a little, so the thrusters are oscillating. You can change, what's the joy gain here?
Good morning, friends and coworkers. How are we today?
Good morning, Monica. Doing well. How are you?
I give it a bit more authority
well.
there
How
on
are
the
you?
thrusters to try and hold its heading.
Sorry, Steph, you're too quiet. What did you say?
Can you hear me?
Yes, but you're just very quiet. What did you say?
Oh, I said I'm doing well. How are you?
Excellent. I am well. And Dan, sorry, what did you say?
I'm gonna let, I'm gonna get Hercules a bit more like under Atalanta, so you'll have to tilt down with your camera a bit more. You can actually see the angle of your camera, what's happening in that picture there with the single gauge in it. So the silver thing going through the bottom left part of the picture is the camera itself. That's what you're adjusting when you... Yeah, it's pretty much immediate. And if you wanted, you could bash on that plus 10 degrees once, and that'll... Yeah, my pleasure. So we had a few holes in the data there where it's, you can see the green voxels, as we call them. It's kind of the orange stuff in the front is the high resolution data, but the computer doesn't have enough horsepower to keep that displayed. It's just a visual display of the actual data we're collecting, so it turns all those into a bigger pixel, basically, and it gives us an idea. So when I bounced around there and changed its heading, it might be a few holes in the... So we're trying to keep that kind of smooth so it collects good multi-beam data. And the less external forces we have on the Hercules, the smoother the ride is. I'm going to try and step to the left again. It's... Yeah, if you want, yeah. Slowly coming back in front of you there. That kind of the goal is to do everything slowly. Any corrections we make so it doesn't skew the data we're collecting.
How far off the seafloor are we?
30 meters.
I see. So is it just really flat?
Yeah. What you see there in the little animated Minecraft world is that's basically real-time data, or what we call waterfall data. So it's a visual display of what the Norbit data is collecting.
Cool. So white's our leading edge, and then yellow is new data, and green's old data?
Orange or gold is the kind of the higher resolution data.
Oh, okay.
But that particular display and software and computer, that's going into a buffer. So at some point we then transpose that data to a lower resolution, which is the green. So a bigger pixel, if you were, or what Chris calls a voxel. That's where we hear us call it a Minecraft world.
Right.
If you're familiar with Minecraft,
Oh, yes.
yeah. So there the data, the buffer filled up, and that chunk was converted to voxels. And now it's going to show us.
And what is the red line?
The red line is, you can't kind of see it from this angle, but those are velocity vector arrows.
Oh, okay.
The velocity arrows, so that's Herc's trail.
I thought it was making his tether look cool.
Yeah, you can see kind of you can see that red line kind of, there's an oscillation to it, or a slight sine wave.
Yep.
That's actually Hercules trail. It's about as tight as we can get the control system.
Very good.
So if we play around with it, that's more of a, the idea is to have a gradual or the minimal oscillation that we can. So depending on how tight we have the gains and the control loop, we've been playing with it for the last hour to get it where it is now.
Neat. And I hear you have a new co-pilot this morning.
Yeah.
How's it going, co-pilot?
Good, this is fun.
Very good.
Good stuff. I've done this for hundreds of kilometers.
I hope that's not today's plan.
Nope. We're not going from Norway to Scotland today. We're just going from trawl resistant frame to somewhere cool. Cork, I think. Somewhere Steve's anxious to get to. So you see on the nav screen my slight corrections here. So I've kind of brought the blue dots, which the pink one is, that's the screen on your left. The pink one is Atalanta, and its heading should match your compass heading there, but there's a slight offset, so don't totally believe that. But it's pretty close. You're looking like close to 315, close to northwest. And that's where Hercules actually is. Those blue dots are USBL pings, so every time Lynette's USBL pings, it gets a response from the transponder on the vehicle and creates a position. The yellow one, which is Hercules, is the position of the DVL that's on Hercules, the Doppler velocity log. And those drift over time. The Doppler has a tendency to drift. So if we weren't using the auto XY functionality, Lynette would physically rehome, what we call rehome the DVL to where the latest smear of blue dots is. Something that often gets us. So the DVL will wander radically if we're going over rough terrain and it loses a couple beams or whatever. It can't tell exactly where it is. You could probably do a click or two to your left now if you want, Ashley. So I'm back where I should be in front of Atalanta.
And would I do that by clicking minus 10 degrees?
Yeah, correct. And you'll see your video up there change when you do that. So you're constantly playing with the heading and the camera angle to kind of keep Herc in the box, as we call it, which the box references your Atalanta video camera. So the camera you're adjusting, you can see Herc go up and down in the screen.
Yep.
So that's obviously what the camera's looking at.
Ashley, did anybody get a picture of you being the fabulous co-pilot you are?
Not yet. We got a picture of Anna, probably.
Oh, watch. Please allow me to step in. 1 second.
Wait, I gotta look like I'm actually doing something here. I'm not. We're basically controlling Hercules and Atalanta with mouse clicks. So the computer's driving. Or more accurately, Lynette's driving.
Thanks. So that's not a school of fish.
So if you want, actually you can, this guy here, if you slowly pull back, you'll see the winch start to move. And then you'll see this number here, the delta, which is also on your screen there. We could probably increase that to between 15 and 20 now that we're back. Our ducks are in a row, as it were. I'm gonna probably 15 is good for now. I'm gonna slow my velocity back down again. That's not good. Can you do me a favor and change your heading a little bit to maybe 315 for a minute? Just got the tether. Yeah, so plus 10 degrees a few times.
And
Or
I'm
sorry.
looking at this for
Yeah.
the heading. Okay.
Yeah, you want it to be 270. It's going to take Hercules out of the view, but that's okay.
And I just keep pushing degrees until it hits 270.
Yeah, roger.
Cool.
Yeah, you can change it a little more. Go ahead and change it to 315 for a minute. Hopefully that's the right size, right side. Okay, if you hold that and then come up on the winch, we'll make that delta maybe 20. What's happening, we have the tether kind of tangled up a little bit there. If you come up nice and easy, that's...
Too fast.
See if I can pull forward a little. Yeah, all good. I just sat down, so yeah, we're good for a while. So what was happening there, the tether was coming off the back of Atalanta, and it's supposed to come down below. It has a weight on it about 10 meters from Atalanta, and then it has 2 football floats towards Hercules. And we had it going kind of around Atalanta there a bit. So by changing your heading, it let the tether kind of stream off behind Atalanta, and then the weight it's back where it's supposed to be, coming around underneath Atalanta, and then kind of does a lazy S down to Hercules. And then I'm increasing my speed a little and stretching it out. It should be, it kind of, because everything is moving, it's kind of streaming behind us. So you should be good, in theory, to change your heading back around to the west. And if you look down a little with your camera, we're trying to get a peek at the tether, see what it's doing. I can look to to your left a little bit more for me.
Oh, can I control the side to side?
Yeah. We can do side to side, but
How would you look to the left?
oh no, you can't with the camera. No, we can.
Okay.
I think we might still be wrapped up there. Basically, all you could do is look up and down with the camera, and then you can change the heading on Atalanta left or right.
Gotcha.
Or if you change the heading to the left a little more, I'll be able to tell if we're
Gotcha.
tangled up or not.
Is that enough, or should I keep going left?
Yeah, we're tangled up. Come back to your right. So I'm probably going to have you actually keep coming clockwise.
Okay.
We're probably going to have to come all the way to the north. What we'll do, since we're kind of tangled up there, is we'll go tail to tail, and then I'll lower, or we'll lower Atalanta down, and that'll get us where we need to be. Either that or we're going the wrong way, but I think it's on the left side.
What heading should I go to?
You can go ahead and keep coming clockwise and look to the east, 090.
Good morning, Nav.
Good morning.
Are you this good at directions when you're in a vehicle?
Good question. I don't know.
I am a little infamous for, you're supposed to turn back there.
Yeah, me too. Forget that I'm
That's
supposed
what I
to be
wanted
giving
see.
directions, and I just assume everyone knows what I know. And then I'm like, oh wait, yeah.
Well, maybe it's like when your mom's a nurse, you know, it's like, you'll be fine, walk it off, you know?
Yep.
To someone else, they're like, let me help you.
Yep, exactly. Yep.
I don't have repressed trauma, don't be silly.
So, I don't know if you caught it there in these two cameras over here. The one on the left is Hercules aft camera, and the one on the right is Atalanta's aft camera. So those where the tethers are coming out of the vehicle. So we picked the right way to turn, and I saw the tether kind of slide off Atalanta and fall away as I lifted it up a little bit. So I think we're good.
So I should come back to the left?
I'm just going to give it a minute here to see what happens. We're about 100 meters from the end of the line, so I might just run it as is for now. The tether between Atalanta and Hercules is 30, 35 meters, something like that. So another thing we use to judge how we manage that is, you know, horizontal separation or vertical separation. So right now our horizontal separation is about, 25 meters. So each of these boxes on the navigation screen is 10 meters with its current zoom level. And judging by my blue smear, I'm, 10, 20 meters in front of you. So if the vehicles are both facing the same way, the tether has to come out the back of Atalanta, sink down below it on the weight, and then come up and do a lazy S. If we're too far away, we go tail to tail. That's basically how we launch the vehicles, and go up and down through the water column. And normally I would stop and we'd get lined up again.